Hello, in this lecture we find out the area of a circle. In the drawing we have a circle. This is called AB. This is equal to 8 units in its length. This is called PQ. This is equal to 6 units in its length. This is angle PMQ, that is the right angle. Again, our task is to find out the area of this circle. So, in the first method, we have already found out that those two angles are equal to each other. Those two peripheral angles. So, if we define the size of this angle as alpha, then this angle must be also equal to alpha because they are equal to each other. Those two angles are defined as vertex angles and they are equal to each other. So this angle equals to 90 degrees in its size. Therefore, this angle must be also equal to 90 degrees in its size because they are equal to each other. So in the right angle PMQ, this angle equals to alpha. This angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. This is the sum of the angles in a triangle. Likewise, in this right angle AMB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha, according to the sum rule that states that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that those two right angles are similar to each other according to angle similarity rule. That is to say, those two angles are both equal to alpha, therefore they are equal to each other. Those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we should prove that all the figures in the right angle ABM are corresponding equal to all the figures of this right angle PMQ. And therefore, those two right angles are similar to each other according to angle similarity rule. So writing down, we should find out that the right angle PMQ is similar. This is the sign of similar to the right angle AMB. According to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of the right angle AMB over side PQ of the right angle PMQ is equal to side AM of the right angle AMB over side PM of the right angle PMQ, and it is also equal to side AMB of the right angle AMB over side MQ of the right angle AMQ. And again, from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of the right angle AMB or side PQ of the right angle PMQ is equal to side AM of the right angle AMB or side PM of the right angle PMQ, and it is also equal to side MB of the right angle AMB or side MQ of the right angle PMQ. AB is 8, according to what is given to the question. and PQ is 6, also according to what is given in the question. And it is equal to AM is the missing side, so we leave it as it is, over PM. PM is also the missing side, so we leave it as it is. And it is also equal to MB over MQ. So in total we found out that 8 over 6 equals to AM over PM equals to MB over MQ. Here we will divide both the numerator and the denominator of this number by 2 and get that 8 over 2 is 4 and 6 over 2 is 3. So this expression equals to 4/3 after we divide it by 2. 4/3 equals to AM over PM. So 4/3 equals to AM over PM. Here we multiply this side of the equation, both the numerator and the denominator by A. It is allowable to divide, to multiply both the numerator and the denominator by A, because A over A is 1, so we don't change the value of the expression by multiplying it by A, and then we divide it by dividing it by A. And get that 4A over 3A equals to AM over PM. So the right side of the equation is equal to the left side. So if AM equals to R by to 4A, then PM will be equal to 3A. The numerator of this side of the equation must be equal to the numerator of the other side of the equation, and the denominator of this side of the equation must be equal to the denominator of this side of the equation. So 4A equals to AM and 3A equals to PM. So here we found out that AM equals to 4A. This is line segment AM, this equals to 4A. And we also found out that PM equals to 3A. And from this equation, we derive that 4/3 equals to MB over MQ. Again, AB over PQ is 4/3. So 4/3 equals to MB over MQ. So here we multiply this side of the equation, both the numerator and the denominator by B, and you get that 4B over 3B equals to MB over MQ. So the numerator of this side of the equation must be equal to the numerator of this side of the equation, and the denominator of this side of the equation must be equal to the denominator of this side of the equation. This is to say, if we found out that 4B equals to MB, or MB equals to 4B, and MQ equals to 3B. So MB equals to 4B. This is 97 MB, this is equals to 4B. MQ equals to 3B. This is 97 MQ, this equals to 3B. PB is a chord. In this circle, PB is a chord. PB is a chord, it is absolutely a straight line. Again, PB is a chord, it is absolutely a straight line. So if you focus on the right side of the straight line PB at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line PB at point M? We have this angle that is right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we will join points B and Q together by a straight line. By joining points B and Q together there, the right triangle MBQ. So I'll go with the right triangle MBQ in a new page and we will implement on it the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Side MB equals to 4B units in its length, side MQ equals to 3 units in its length, and the hypotenuse BQ is the missing side. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle BMQ that is coming from the original drawing. This right triangle BMQ, BQ squared, that is the square of the hypotenuse, equals to MB squared plus MQ squared. So I write it down. BQ squared, that is the square of the hypotenuse, equals to MB squared plus MQ squared. BQ is the missing side, so we leave it as it is, so it is BQ squared equals to MB squared. MB is 4B, therefore MB squared is 4B squared, that is 16B squared, plus MQ squared. MQ is 3B, therefore MQ squared is 3B squared, that is 9B squared. So in total we found out that BQ squared equals to 16B squared plus 9B squared. So BQ squared equals to 16B squared plus 9Q squared is 25. Again, BQ squared equals to 16B squared plus 9B squared. 16B squared plus 9B squared is 25B squared. So in total we found out that BQ squared equals to 25B squared. Here we take a root out of this equation and finally get that BQ equals to the square root of 25 is 5 and the square root of B squared is B. So BQ equals to 5B square units in its length. This is the missing line segment BQ that is equals to 5B square units in its length. So what is the area of this triangle ABQ? Actually, you can find out the area of this big triangle ABQ in two different ways. We know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So from one side, the area of this big triangle ABQ is equal to the base AB times the height to the base, that is MB, over 2. So the area of the big triangle ABQ from one side, the area of triangle ABQ equals to the base of the triangle. We'll choose the base SAQ times the height to the base, that is MB, over 2. But from the other side, you can calculate the area of this big triangle ABQ in a different way. We have a formula that in any triangle, this is triangle ABC, that could be any triangle, the area of this triangle ABC will be equal to A times B times sinus theta over 2. So in the formula we have triangle ABC, the length of side AB is A units, side AC equals to B units in this length, side BC equals to C units in this length. This is angle theta, angle BAC equals to theta. So the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. So the area of a triangle is equal to the multiplication of two sides by each other times the angle between the two sides over 2. Okay? We use this new formula in order to calculate the area of this triangle, triangle ABQ. So the area of triangle ABQ from the other side will be equal to the multiplication of two sides by each other. This is actually side AB times side BQ times sinus the angle between side AB and side BQ. So it is sinus angle ABQ. This is angle ABQ times sinus angle ABQ divided by 2. Because again, from one side, the area of this triangle ABQ is equal to the base AQ times the height MB over 2. But from the other side, the area of this triangle ABQ is equal to the multiplication of two sides by each other, that is AB times BQ, times the angle between the two sides, that is actually angle ABQ, divided by 2. So the area of triangle ABQ according to the first method must be equal to the area of triangle ABQ according to the second method. But what is the value of sinus ABQ over sinus ABQ? What is the value of sinus ABQ? In order to find out the value of sinus ABQ, we use the law of sines. The law of sines is true in any triangle. This is triangle ABC, that could be any triangle. Side AB equals to C units in its length, side AC equals to B units in its length, side BC equals to A units in its length. This is angle alpha, this is angle beta, and this is angle gamma. So in this triangle, triangle ABC, that could be any triangle, the following equation is true. That A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Again, this triangle ABC, that could be any triangle, the following equation is true. That A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And it is equal to 2R. 2R is the radius of the circle that blocks triangle ABC. Again, R is the radius of the circle that blocks triangle ABC. the radius of this circle. So we use the law of sines in order to find out the value of sinus angle ABQ. According to the law of cosines, if we implement the law of cosines, this triangle ABQ, actually triangle ABQ is blocked by this circle. Again, triangle ABQ is blocked by this circle. So according to the law of sines, we get that AQ over the angle that is in front of side AQ, that is angle ABQ. So according to the law of sines, AQ over sinus the angle between in front of angle AQ, this is angle ABQ, equals to 2R, and R is the radius of this circle that blocks triangle ABQ. After we will find out the value of R, to find out the area of this circle is very simple, because we will square the radius, we will multiply it by pi, and pi r squared is the area of this circle. That is the area that we are looking for in this question. So we are interested to find out the radius of this circle. So according to the law of sines, in this triangle ABQ, AQ over sinus angle ABQ equals to 2R. Then in the right triangle ABQ, AQ over sinus angle ABQ equals to 2R. So here we multiply this equation by sinus ABQ, because we are interested to find out the value of sinus ABQ, sinus angle ABQ. And we get that. So we multiply this equation by sinus ABQ, and then we divide it by 2, and this way we will find out the value of R. So R will be equal to, or actually sinus ABQ, we multiply it by sinus ABQ, so sinus angle ABQ equals to AQ over 2R. Again, AQ over 2R is value of sinus angle ABQ. Actually, we multiply this equation by sinus ABQ, and then we divide it by 2R. Simultaneously, in this way we found out that sinus angle ABQ equals to AQ over 2R. Now we can substitute sinus angle ABQ in this equation by AQ over 2R. We do it now, and we get that AQ times MB, AQ times MB over 2 equals to AB times BQ over 2 times sinus angle ABQ times sinus angle ABQ. And we already found out that sinus angle ABQ equals to AQ over 2R. Therefore, we substitute sinus ABQ by AQ over 2R. AQ over 2R. Here we have 2 on both sides of the equation, so 2 will get cancelled. And we're left only with AQ times MB equals to AB times BQ times AQ over 2R. Repeat again. In total, we found out that AQ times AB equals to AB times BQ equals AB times BQ times AQ over 2R. Here we have AQ on both sides of this equation, so AQ will get cancelled. After we cancel AQ, in this side of the equation, we're left only with MB. So MB equals to AB times BQ over 2R. Here we will divide this equation by A and B, and we divide this equation by a and b, and then we multiply it by r simultaneously in order to find out the value of r. We get that r equals to ab times bq over 2 times mb. Again, actually, we multiply this equation by r, and then we divide it by mb simultaneously. In total, we found out that the radius that we are looking for this question is equal to ab times bq over 2 times mb. So the radius r equals to ab equals to 8 units in its length according to what is given as a question. So AB by 8 times BQ. BQ equals to 5B. Again, BQ equals to 5B over 2 times MB. So it is 2 times MB. MB is 4B. So it is 2 times 4B. So in total we found out that the radius of the circle, the radius of this circle, that is the radius that we are looking for, is equals to 8 times 5b over 2 times 4b. 2 times 4 is 8, so 8 over 8 is 1. So this expression will get cancelled, and we left only with r equals to 5b over b. 5b over b is 5. So I should found out that the radius of this circle r equals to 5 units in its length. The area of any circle equals to pi times the radius of the circle squared. And therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is r, therefore the radius squared is r squared. So the area of our circle equals to pi r squared. So it is pi times r squared. R is 5, therefore r squared is 25. 5 squared is 25. So total we found out that the area that we are looking for in this question, that is the area of this circle, equals to either 25 pi square units in size, or in terms of numbers, is equal to 78.54 square units in its size. And again, we found out that the area that we are looking for in this question, this is the area of this circle, it is equal to either 25 pi square units in its size. In terms of numbers, the area of this circle equals to 78.54 square units in its size. So the next step, we'll start the lecture. Our task in this lecture is to find out the area of this circle. So in the drawing we have chord AB equals to 8 units in its length, chord PQ equals to 6 units in its length. We already found out that in the first method that those two peripheral angles are equal to each other. So if this angle is this peripheral angle is alpha, then this peripheral angle must be also equal to alpha because they are equal to each other. Those two angles are vertex angles and they are equal to each other. But this angle equals to 90 degrees, and therefore this missing angle must be also equal to 90 degrees because they are equal to each other, according to the rule that vertex angles are equal to each other. So in the right angle A and B, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees plus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in the triangle. Likewise, in this right triangle PQM, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha, according to the sum rule that the sum of the angles in the triangle is equal to 180 degrees. It is very easy to see that those two right angles are similar to each other according to angle similarity rule. That is to say, those two angles are both equal to alpha, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. We found out that all the angles of this right triangle A and B are correspondingly equal to on those three angles of this right triangle PMQ, and therefore those two right triangles are similar to each other, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of the right triangle AMB over side PQ of the right triangle PMQ is equal to side AM of the right triangle AMB over side PM of the right triangle PMQ, and it is equal to side MB of the right triangle PMB over side MQ of the right triangle PMQ. And again, we derive that AB over PQ equals to AM over PM equals to MB over MQ. AB is 8 and PQ is 6. Here we divided both the numerator and the numerator of this expression by 2, and 8 over 2 is 4, 6 over 2 is 3. So this expression equals to 4 thirds. So 4 thirds equals to AM over PM. Here we multiply this side of the equation by A, and then we divide it by A. By multiplying it by A and then divide it by A, we change nothing because we multiply it by 1. It is allowable to multiply an expression by 1. So in total we found out that 4A over 3 equals to MA over PM. So those two sides are equal to each other in this equation. Those two sides will be equal to each other only if the numerator on this side of the equation will be equal to the numerator on this side of the equation. So that is to say 4A equals to AM, or AM equals to 4A, and the numerator of this side of the equation will be equal to the numerator of this side of the equation. That is to say 3A equals to PM. So in total we found out that AM equals to 4A and PM equals to 3A. So this is side AM, this equals to 4A units in its length, and this is side PM, this equals to 3A units in its length. From this equation, we derive that in this side of the equation we have actually 4 thirds is equals to MB over QM. Again, 4 thirds equals to MB over QM. 4 thirds equals to MB over QM. Here we multiply this side of the equation, the numerator of this side of the equation by B, and then we divide it by B. We found out that 4B over 3B equals to MB over MQ. So the numerator for B in this side of the equation must be equal to the numerator of this side of the equation, that is to say 4B equals to MB, and the denominator on this side of the equation must be equal to the denominator of this side of the equation must be equal to the denominator of this side of the equation, that is to say 3B equals to MQ. So in total we found out that MB equals to 4B, MQ equals to 3B. This is side MB, this is equal to 4B, and this is side MQ, this is equal to 3B. PB is a chord in this circle, and PB is a chord, it is absolutely a straight line. So if we focus on the right side of the straight line PB at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have the right side of PB at point M, we have this angle that is the right angle according to all this given equation, plus this missing angle, so that the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step, we join points B and Q together by a straight line. In this way, we created the right triangle BMQ. So copy the right triangle BMQ in the new page and we implemented on this right triangle BMQ the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. Okay, this is the right triangle BMQ. As I copied from the original drawing. In this right triangle BMQ, BQ squared, this is the square of the hypotenuse, equals to MB squared plus MQ squared. BQ is the missing sign, so we need to see this. So it is BQ squared equals to MB squared. MB is 4B, therefore MB squared is 4B squared, that is 16B squared, plus MQ squared. MQ is 3B, therefore MQ squared is 3B squared, that is 9B squared. So in total we found out that BQ squared equals to 16B squared plus 9B squared. 16B squared plus 9B squared is 25B squared. So in total we found out that BQ squared equals to 25B squared. Here we took out of this equation, we found out that BQ equals to the square root of 25, that is 5 times square root of B squared, that is B. So in total BQ equals to 5B. This is line 70, BQ or side BQ, is equals to 5B units in its length. In the next step we focus on this big triangle, triangle ABQ. We calculated the area of this big triangle ABQ in two different ways. For one side, we know that the area of any triangle equals to the base of the triangle times the height to the base over 2. We choose the base as AQ, the height to the base is MB over 2. For one side, the area of this triangle ABQ equals to the base AQ times the height to the base, that is MB over 2. Repeat again. From one side, the area of triangle ABQ equals to the base AQ times the height to the base MB over 2. But from the other side, you can calculate the area of this triangle ABQ in a different way, according to the formula that the area of this triangle, triangle ABC, that could be any triangle. We know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Angle BEC equals to theta. So in this triangle ABC, that could be any triangle, therefore the area of this triangle ABC, that could be any triangle, is equals to A times B. It is the multiplication of two sides by each other, times the angle between the two sides over 2, times sinus the angle between the two sides over 2. That is to say, this triangle ABC equals to A times B times sinus theta over 2. Again, this triangle ABC equals to A times B times sinus theta over 2. We use this new formula in order to find out the area of this big triangle, triangle ABQ. The area of this big triangle ABQ will be equal to AB times BQ. That is the multiplication of two sides of this triangle times the angle times sinus the angle that is between those two sides over 2. That is sinus times sinus ABQ, angle ABQ over 2. So from the other side, the area of triangle ABQ equals to side AB times side BQ times sinus the angle between the two sides over 2. So the area of triangle ABQ according to the first method must be equal to the area of triangle ABQ according to the second method. So here we have to find out the value of sinus angle ABQ. What is the value of sinus angle ABQ? In order to find out the value of sinus angle ABQ, we use the law of sines. The law of sines is to an any triangle. This is triangle ABC, that could be any triangle. This triangle ABC, side AB equals to C units in its length, side AC equals to B units in its length, side BC equals to A units in its length. This is angle alpha, this is angle beta, this is angle gamma. And we have here a circle that blocks this triangle. In the equation we have R. R is the radius of this circle that blocks triangle, ABC. So, according to the law of sines, the following equation is true. That A over sinus alpha equals to B over sinus beta equals to C over sinus gamma equals to 2R. And R is the radius of the circle that blocks this triangle ABC. Again, according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So we can use the law of sines in order to find out the value of sinus angle ABQ. According to the law of cosines, AQ over sinus angle ABQ equals to 2R. Again, AQ over sinus angle ABQ equals to 2R. According to the law of sines, AQ over sinus angle ABQ equals to 2R. And R is the radius of this circle that blocks this triangle ABQ. And again, according to the law of sines, AQ over sinus angle ABQ equals to 2R. So here we multiplied this equation by sinus angle ABQ, and then we divided by 2R, and finally found out that sinus angle ABQ equals to AQ over 2R. Again, sinus angle ABQ equals to AQ over 2R. Therefore, we can substitute sinus angle ABQ in this equation by AQ over 2R. We did it, and we found out that AQ times MB equals to AB times BQ, and sinus angle ABQ equals to AQ over 2R. So total AQ times MB equals to AB times BQ times AQ over 2R. We have 2 on both sides of this equation, so 2 will get cancelled. And we have here AQ on both sides of this equation, so AQ also will get cancelled. After we cancel AQ, in this side of the equation we left only with MB. This is equals to AB times BQ. Again, MB equals to AB times BQ over 2R. Here we multiplied this equation by R, and then we divided by MB simultaneously, and found out actually that R, that is the radius of the circle that we are looking for in this question, is equal to AB times BQ over 2 times MB. Again, R, the radius of the circle, is equal to AB times BQ over 2 times MB. So R equals to AB. AB is 8, according to what is given in the question, times BQ. BQ is 5B. So we substitute BQ by 5B over 2 times MB. MB is 3B. MB is 4B. So we substitute MB by 4B. So it is 2 times MB, and MB is 4B. So total we found out that the radius of the circle that we are looking for is equal to 8 times 5B over 2 times 4B. We have 8 in the numerator, and 2 times 4 is 8. So 8 over 8 is 1. So 8, 2 and 4 will get cancelled, and we left only with R. This is equal to 5B over B. B over B is 1, so R equals to 5. So we found out that the radius of this circle is R equals to 5 units in its length. Our test is to find out the area of this circle. Actually, we know that the area of any circle equals to pi times the radius of the circle squared. And therefore, the area of this circle must be equal to pi times the radius of our circle squared. The radius of our circle is R, therefore the radius squared is R squared. So in total, the area of this circle equals to pi R squared. R is 5, so R squared is 5 squared, that is 25. So in total, we found out that the area of this circle, that is the area that we are looking for in this question, is equal to either 25 pi square units in size. So in terms of numbers, the area of this circle equals to 75.44 square units in size. Again, the area of this circle equals to 78.54 square units in size. So in terms of numbers, the area of this circle equals to 25 pi square units in size. Okay, thank you very much.